Now, in continuation of this question, we've only found the value of the resultant flux here, but it still remains the direction of that particular flux, which is the theta. So to find that direction, we make use of this formula, that is tan theta equals to, that is an Fy divided by Fx. So this is the formula, Fy divided by Fs. And don't forget that Fy is the first component, under the J, under the J axis, which is the Y axis there. Then, and what is the value there? We have the value of what? -2. You don't need to write -2J. Just write the coefficient of J there. That is -2. So then divided by, then the Fx. What is Fs? Fs is 1. Yeah. So by looking at it, then we have what? That is tan theta equals to, that's -2, right? So then theta will now be what? So theta will now be, that is a arctan, that's arctan -2. So arctan -2. So what do we get there? Find arctan -2. So the answer gave us that's 60, that's -63 now. 63 point, -63.44, that's 43 degree. So that is it. So that is the theta here. So they now ask us that, okay, if we now arrive at -63.43 degree, in what direction does this resultant flux, really lies? In what direction does it lies? And that one will now bring us back to the aspect of the, bearing, the bearing concept now, with respect to the cardinal point. So that is what we are going to apply. So by looking at that bearing, so let's look at the four cardinal points we have here. Let's do the four cardinal point. Now we have two forces. Now we have one here which is acted in this direction. Let's call this one to be F1. And don't forget that the other force will be acted in the opposite direction to this. Don't forget that we have other force acted in the opposite direction. That, let's call it F2 now. So this F1 we have here represent the Fx. Let me call it Fx now. Fx, because it has positive conventional sign. Then the Fy we have here represent, that's F2. So the F2 here, don't forget that the Fy we have here is in opposite direction, because of the negative, this negative value we have here indicate that the vector is in opposite, direction. The force is in opposite direction to Fx. So it's going to act in opposite direction. That is why the arrow is pointing towards the opposite direction, because it carries the negative conventional sign. Now, where do we now have the resultant now? We say that resultant here lies on this particular